Welcome to my channel Ganitavayini. I am HarshaVardhana. Here we start with the theorem. The number of permutations of n different objects taken or at a time where 0 is less than or is less than or equal to n and the objects do not repeat is n into n minus 1 into n minus 2 so on to n minus r plus 1, which is denoted by npr or p of n comma r, that is equal to n factorial over n minus r factorial. So the proof of number of permutations of n different objects taken or at a time p n comma r is derived using the fundamental principle of counting. Here we follow step by step. To find the number of ways to arrange all objects from a set of n, we fill all distinct positions. First positions, it can be filled by n objects. Second position, it can be filled by remaining n minus 1 objects. Therefore ways is equal to n minus 1. Third position can be filled by any of the remaining n minus 2 objects, and rth position can be filled by any of the remaining n minus r minus 1 objects, which simplifies to n minus r plus 1. Then applying the multiplication rule according to the fundamental principle of counting, the total number of permutations is the product of the number of ways each position can be filled. Therefore p of n comma r is equal to n into n minus 1 into n minus 2 so on to n minus r plus 1. In that, we are simplifying to factorial notation. To convert this product into standard factorial formula, we multiply and divide the expression by n minus r factorial, which is the product of p of n comma r is equal to n into n minus 1 so on to n minus r plus 1 into n into n minus 1 minus r minus 1 divided by n minus r into n minus r minus 1 so on to 1. The numerator shows the product of all integers from n down to 1, which is n factorial. And the denominator is n minus r factorial. Therefore final formula p of n comma r is equal to n factorial over n minus r factorial, or this can be proved by p of n comma r is equal to n into n minus 1 into n minus 2 into n minus 3 so on to n minus r minus 1 ways. This can be written as p of n comma r is equal to n into n minus 1 into n minus 2 into n minus 3 so on to n minus r plus 1, which called as equation 1. Multiplying and dividing 1 by n minus r into n minus r minus 1 into n minus r minus 2 so on to 3 into 2 into 1, we get p of n comma r is equal to n into n comma n minus 1 into n minus 2 into n minus 3 so on to n minus r plus 1 into n minus r into n minus r minus 1 into n minus r so on to 3 into 2 into 1 divided by n minus r into n minus r minus 1 into n minus r minus 2 so on to 3 into 2 into 1. Therefore p of n comma r is equal to n factorial over n minus r factorial. Hence the permutation formula is derived. Calculate the following NP. When n is equal to 12 and r is equal to 5, therefore npr is equal to 12p5, that is equal to 12 factorial over 12 minus 5 factorial, that is 12 factorial by 7 factorial, that is 12 into 11 into 10 into 9 into 8 into 7 factorial over 7 factorial. 7 factorial, 7 factorial get cancelled. We left with 12 into 11 into 10 into 9 into 8, that is 95,040. Then 9p4, 9 factorial over 9 minus 4 factorial, that is 9 factorial by 5 factorial, that is 9 into 8 into 7 into 6 into 5 factorial over 5 factorial. 5 factorial, 5 factorial get cancelled. We left with 3024. Here we see the special cases. The number of permutations of n distinct objects taken or at a time where order matters and repetitions are not allowed is p of n r is equal to n factorial over n minus r factorial. When all the n objects are arranged, the total permutations are n factorial. If repetitions are allowed, the total is n to the power of r. Key formulas and the concepts. Permutations of n distinct objects is n factorial, that is n into minus 1 so on to 1. Permutations of n objects taken or at a time. npr is equal to n factorial over n minus r factorial. Permutations with repetition allowed is n to the power of r. Permutations of multisets. If n objects have p1 similar objects of type 1, p2 of type 2, the formula is n factorial over p1 factorial into p4 factorial so on to pk factorial. Example, the number of permutations of 3 letters from the set ABCD is p of 5 comma 3 is 5 factorial over 5 minus 3 factorial, that is equal to 120 by 2, that is equal to 60. If r is equal to n, the formula p of n comma n simplifies to n factorial over n minus n factorial, that is n factorial over 0 factorial, that is equal to n factorial. Since 0 factorial is 1, find the number of permutations. N is equal to 9 and r is equal to 3. Given n is equal to 9 and r is equal to 3, using the formula given above for permutations, npr is equal to n factorial over n minus r factorial, that is 9 factorial over 9 minus 3 factorial, that is 9 factorial by 6 factorial, that is 9 into 8 into 7 into 6 factorial over 6 factorial. 6 factorial get cancelled. We left npr is equal to 504. In how many ways can 5 different books be arranged on a shelf? This is a permutation problem because the order of book matters. Using the permutation formula, we get 5p5, that is 5 factorial over 5 minus 5 factorial, that is equal to 5 factorial over 0 factorial, that is 5 into 4 into 3 into 2 into 1 by 1, that is 120, because 0 factorial is 1. Therefore, there are 120 ways to arrange 5 different books on a shelf. With this session, I will conclude. Those who have any clarifications or any doubts regarding to this problem or regarding to these videos, please feel free to ask. And those who have not attended the session or class, uh, put the comment on the comment box. I will rectify the same, and those who did not see the video, I put the link in the description box. You can click on the link and see the video. And those who like the videos or notes, please like it, share it, and subscribe the channel.